Hello there folks once again. So having rebuilt that chassis from the Harvard H403 Good Buddy, and yeah, I noticed the transmitted audio was on the muffled side, but it doesn't mean the radio is on the muffled side. I used a random microphone, didn't I, found in the box. Had I done our standard replacement mic, it may have sounded better. Right, it's like Uniden sets, and this is what we're going to do today. They sound muffled on the factory original mic, but a different mic can often improve that, and that's exactly what we'll be doing. This is out of the batch we bought from Lancashire, so we will be selling this one on eBay, so it's just here as a demonstration. So what we'll do, notice straight away that the power connector's missing. So I'm sure we've got enough scrap stuff to sort that out. Now these always need those 4 capacitors changing, so I'm not going to power it up without doing that thing, or we're going to end up with no display or a duff audio amplifier, and the last thing we want to do is to destroy either the phase lock loop chip or the audio amplifier chip, which is both, well, the phase lock loop chip is non-available now. After all these years, I'm going to have to take all the lids off, aren't we, to do those capacitors. It's got self-tappers in and all kinds of things, this has. So we may end up having to re-tap the threads. Right. That's a problem because the speakers of these are unique and they're 16 ohms. I might have to pinch one off one of our sets which has a knackered phase lock loop. So that's another thing you can't replace on these, 16 ohm square speaker. We'll be able to sort this out as far as the socket goes, but just in case it's a no-hoper, rather than do... Oh, well, that's good, isn't it? Because the wires come off. Yeah. It's not a good start, this, is it? Right, anyway, what we're not going to do is risk switching it on with, where's my glasses, with those capacitors. So it's 470, 470, 220, 220. And the positive is the white dot. I'll test these. This really, so I'll just pause the video while we see. Bet the meter's jammed as usual, isn't it? So what we do have here is a realistic. This is how I've bought it. It probably had the phase lock loop chip in it, but that's how I've bought it. I would never remove presets because they're so cheap, well, relatively cheap. But I bought that, probably paid £2 for it, but you see it's got the power connector, and it's got the decoupling capacitors, and what we don't want it to do is to start putting strange things through. But you see, this has lost its chokes, its power input chokes, so we're going to replace the power input chokes as well, because otherwise you're going to end up with hums when it transmits and things. So important to not let this happen. I don't know what I'm unsoldering. It's not. There we go. Right. I'll pause the video. We'll just transfer that connector across. Right. So we've transferred the socket, the important ferrites, the decoupling capacitors. So where it was before, just got the wires going straight in. I've no doubt it powered up that way, but that's how you're going to get interference in the set, and end with it humming on transmit, a bit like a Murphy DS602 or a York 867. Right, so we're powered up. We'll go straight for it because I've done the capacitors. Oh, and it's come straight on. Right. Oh, meter lamp works, much more than the meter does. You know what? It transmits. Obviously, we've got that meter to look at. Let's go into picture in picture, and we'll start filling out the form. So, channel 20. It is it is as well doing 3.6 watts. And I've got some things in the way. Oh, I don't know if I'm in the PA socket. I'll just go for that first. Testing 1 2, testing 1 2, 1 2, testing 1 2, testing 1 2. So I don't know which socket's which because the label's so unclear. Testing 1 2. We've got very low volume. Something smells hot. One two, 1 2. I may just check that's that mic. These seem to get fiddled with, you know. Someone says, "Oh, I think we'll have it wired Cybernet and all that malarkey." So I don't know. Let's have a look whether there's audio. Wallow. No, there's no transmitted audio. So we've got no receive, no transmitted audio, no PA. And transistor 19 is getting too hot. We'll just go through this. 3.6 watt. None. A meter lamp works. So I have to get the circuit. I'm going to switch it off. Oh, before I do that, I'll just put the signal generator on. And see whether it's actually receiving at all. So it is receiving its dodgy squelch. The squelch is so heavy on that it's not. It gives the impression of not receiving. So just deal with the squelch. See if we can override that. That could be where this is not right. That transistor's far too hot. There we go. The controls want spraying, but it's now hissing, which is what we wanted. No transmitted audio, no PA audio. Well, I'll tell you what we will do then. Is we'll just get the cyanide reading done. So not as sensitive ever as Cybernet sets, but they're always adequate and they're well loved. 0.7, probably about where it should be, to be honest. Tends to be good for bleed over because of that. 0.58. If it will do 20, it will. 0.55. No, 1.75. So as it was presented, it was never opening. Obviously the meter's faulty. We can't find that. PA's not working. No transmitted audio. Low power. Uh, 360 milliwatts. High power current. 762 milliamps. Good. So need to overcome what the problem is there. So we've got no audio, and that volt in that transistor 19 is getting hot. So if I dig out the realistic service manual, and while I do that, I'll just put the video on pause. Right, we'll look at some circuit diagrams. So this is a scan from the instruction book of the genuine Uniden 100 circuit diagram. Because the realistic one, this was a photocopy, and I scanned the photocopy, and so you've got a loss of resolution. So this is better. So we'll use the service manual for the realistic, but so we're looking at the audio, which I presume goes in on pin 2 if I knew where my thing was. Yeah, it's be pin 2. So basically it goes into the NJM 4558 to amplify and speech process it, and it eventually finds its way across to the varicap diode 7 in the phase lock loop section to actually apply the audio to do the frequency modulation. If you remember, you're varying the width, you're not actually making it louder, you're varying the width. Deviation controls there. So if there's no transmitted audio, of course with PA it's not going to go through all those stages, so it could be quicker to sort the PA out, but hey, it might be more fun if we do it on transmit. So I'm going to put my walkie-talkie on. So if I find a deviation, here's the shortcuts. Find a deviation control, switch the radio on. We'll worry about this. I think there's probably a capacitor gone short circuit, and that's probably why that's getting hotter than I would expect. Now the set right now is drawing 330 milliamps, which isn't stupid, but I'd expect it to be more like 230 milliamps. So there we go. So we've got no transmit audio. Just check. 1 2 1 2 1 2 1 2 1 2 Wallow. 1 2. No, see, you can hear me keying up. So if I put my finger, I'm using a metal screwdriver, and if I put my finger on the deviation control, I would expect a buzz. So I can hear myself generating that. Whereas if we went on the microphone pin, we're still going to generate a buzz. So that was not a good demonstration. I'll tell you what, we'll just put the PA speaker in the PA socket. And we'll do it the PA way for a moment. So we're looking at the audio going in on pin 3. And we've got nothing when I click on that. Coming out at pin... Hang on, I've blown these up so I can read them. So that's looking round the transistor that's getting hot. No, that's looking at the deviation. That's what I want. So we've just checked it on pin 3. Let's check it on pin 1. Again, we've got an electrolytic capacitor there. So if that was short circuit, that wouldn't work properly. Absolutely nothing. So looking at the next part of the same chip, let's look at pin 7, which is where it comes out. I've got no clicks from there either. We'll go back to CB mode. We'll do that test again. Pin 7. Definitely got something there. Pin 1. Well, I'm going to do some sensible capacitor change here. If that's clearly on the output, so capacitor 96 is on the output, capacitor 95 is interstage. So 4.7 and 4.7. We've also got, that could have an effect, 98 and 91 could also have an effect. So we've got 4. For what it's worth, let's change all 4 and we'll check them later. So using the, I was going to say using the other manual, I'll just turn the power off. Can we actually see where these capacitors are? So 95 and 96. I'll just unplug the mic so it's a bit easier. 95, 96. Well, 96 is that one, so that's easy. And 95 is that one. So 95, 96. So we'll get rid of those. Did I switch the soldering iron on? No, of course I didn't. Can't see those, that's why we'll go for the service manual. So 90, what do we do? 95 and 96 we've already taken out, which was that one and that one. So now it's 91 is that one. 91 and 98. Just next to it, 91 and 98. Right, so that is 1, that is 22, and 2 4.7s. Yep. Yep. Right. Out of interest, one of the 4.7s is, that reads okay. It's not 100%, but it's okay. And that's okay. Oh yeah. That's okay. And that's okay. But it doesn't mean they are okay and they're going to get changed. Okay, so we've done those. So what was it? 1 microfarad, 22 microfarads, 4.7 and 4.7. Right, moment of truth, switch on channel 20. Testing 1, 2, testing 1, 2. Oh, good, we've got translated audio. Let's see if we've got PA. Testing 1, 2, testing 1, 2, 3. On these sets you can't adjust the volume. Right, well that's fixed that, hasn't it? So they read okay on the tester, but they're not okay, and that's something that can happen. But what are we, you know, like 16 pence each? I've just changed all 4, haven't I? I could have done them piecemeal, but I didn't. So there we go. Thank you, Realistic Service Manual. You've been useful once again. You can see where I'm getting from here. We've got the transmitted audio coming in from the mic. It goes into pin 3 of the NJM 4558, which is an operational amplifier. It's a dual operational amplifier. It's got 2 things in the one 8-pin package. So you've got amplification here, you've got speech processing here, and you can see that if pin 2 was, if that was short circuit, and it wasn't short circuit on the tester, but if it was, the voltage would be robbed, wouldn't it? It's got a 560 ohm resistor there, but it could be robbed and you could end up with a loss. And conversely, on this one, this isn't likely to have been the culprit, because on pin 3 you're passing the audio through that capacitor. If that was short circuit, well, that resistor's 27k, so come on, it can't have that much effect, but I've changed it. And then here, if you've got the output there and it was being dragged down by this capacitor, you've got 270 ohms to deck. And then finally you've got this one, which is coupling between the 2 stages, and if that was iffy or open circuit or whatever, it would be very, you know, it would be a bit dodgy, wouldn't it? So I'm just going to poke me, was it pin 1 was the one we were poking? Let's put the power back on. It's difficult now, it's working. Tell you what, we'll go back to CB. Pin 1. Pin 7. it's difficult now. It's working, but you can see where I was getting from. I could have used a signal injector. We've got one somewhere. I made one as well, but you know, are they ever here? No. Right, so that's solved that. Let's just have a look. I think this has got robbed down the line at some point. You know, it's a non-working set. The meter's jammed. I think the power connector's probably found its way on another set. And obviously, I bought it from mate in Lancashire, and I don't think he's been into it. You know, it's a batch of untested sets. But we always need to change those 4, and on this occasion, I've changed those 4 as well. Right, but the question is it worth it? Because they don't fetch much money. You get more for a Fidelity 1000, it seems to me, or a Maxcom 4E, even though these are a better quality set. You know, horses for courses. Right, deviation. I haven't altered it in any way. Wow, it's 4.2 showing on this one. Well, I'll tell you what, let's get that sorted out with the other test set. See whether it really is 4.2 or whether my Marconi one is playing up. Right, see what the deviation is on the quartz lock test set. Wow, oh, miles out, about 14 or whatever. Right, mind you, somebody could have cranked that up to full to try and find the missing audio. Wow, done. Turn that off. Not sure where we're going to get a speaker from. I can get them for £16 something or other. You know, it's well and good spending all that money and then getting 30 quid for a set you've just spent 40 on. Right, deviation on this test set says wow, it says 1.8, so it's lying today. So it's 2.2 to 2.5 kilohertz. Good. So that should sound all right now. Testing 1 2, testing 1 2 3 4 5. Good. We're not going to do the VCO on this. I've shown that many times. It's never been disturbed, so there's no point in rattling its cage. Let's see what the other channels are doing. Channel 40 is doing... oh, that's rubbish. 2.3 watts. That's a big difference. And channel 1 is doing 2.3 watts. It was 2.6, it wasn't 3.6. That's where we've gone wrong. Right, we'll go through the tune-up. Not sure we're going to gain all that out of it. So on channel 20. Well, that wasn't central for a start. .5. I can never remember whether that's receive or transmit. Well, it's not having any effects, it must be receive. Why isn't that going anywhere? We need to get a bigger one out of stock. I don't know where these go. I think there's a planet somewhere. Right, so we're at 2.5. Two and a half, or something's not happy, is it? Anyway, I'll move on to receive. Come back to transmit. So I'm going to start with the oscilloscope with 100 microvolts on the signal generator. Those still need cleaning. So, which one's the detector? Is it that one? And how does that affect things? Right. So go over to the snag meter. And what I haven't done is we'll just check what frequency this thing's on, because with them being non-adjustable, I want the transmit and receive to be on the same frequency, don't I? 27.79113 is absolutely fine. 27.79113. So we need to equal that for receive. 27.79113. We could end up with it lopsided. It's all very close. That will do nicely. Go back to the snag meter. Drop that to about 4 dB and start with the first coil. That was absolutely spot on. That was absolutely spot on as well. I've disturbed this one. It's having no effects. It could well be transmit. Have I forgotten? It's L14. Transmit L14. Yeah, it's transmit. Let's go back to transmit. There we go, that's corrected that. It's not made any difference, it's still 2.5 watts. So back to receive. Absolutely perfect. You know what, there's the tiniest thing there. Put the bigger signal on. smaller signal on. Might be able to read it one day. Let's look at the shape of it with the oscilloscope. It looks about there. Let's just turn the squelch down. Or up. I think we're about there. Finally, as part of the VCO setup, when you initially set these up, we set this up for a voltage with the oscilloscope. Now I haven't touched that, so I shouldn't need to touch this, but just out of interest, just in case it's ever been touched. No, that's spot on. So we'll get a new reading, but I don't think we're going to be any different. .57. Well, I don't know where we got that from. 0.5 on the dot. UV, thank you, and 20. Perhaps we've made it worse. It's 1.55. Squelch. So full squelch. Is a very coarse 9.2 millivolt. Let's just see where the threshold is. Wrong one. .62. So we've already set squelch to maximum sensitivity, so it's a lousy 9.2 millivolts. But there's no hard and fast rule on that. We need to get to the bottom of why the transmitter's only... just shut the speaker leads out. Only doing 2.6 watts. It's probably something quite logic, and we need to get to the bottom of the meter. So if I key up, what happens? Does the meter try? Yes, I think it does. So one of the things that can happen is this bearing. Out of all the meters we see, apart from Midland 48, these seem to have worn out the quickest. We need to raid Mr. Chippy's bench for a precision screwdriver. We'll just start this transmitter again. I've realised what's happened. I've gone through it on low power, haven't I? I'll just go back to bed, get up again, and we'll start again. It's now doing 4.4 watts. So re-centralise that, because it's going to be different on low and high power. So we've got 4 watts there. On channel 40 and 1, channel 1 got bang on 4 watts, and on channel 40 we've actually got 4.05 watts. It's now drawing 1.12 amps, which is what we now expect. And low power clearly needs adjusting. Because it's doing 2.2 watts. Now doing 400 milliwatts. So our only problem now is the meter. So I'll go and raid Mr. Chippy's bench. Right, I've managed to unjam it. I took the meter out and slightly backed off the lower screw, and we've now got a meter that does something on both transmit and receive. So I'll get the power back off, and hopefully we'll put that back together. Notice we've got these lugs collapsing. Right, well, we'll align that. So on the receive side, there's S9. I'll tell you what, let's do a before reading. It's virtually spot on, you know. It's 220. So I'll write that down on the sheet. And on transmit, it's full scale deflection, so we need to drop that off. Centre of the red zone is where we are. Low power, high power. Right, well. I'll just kind of tighten these up. Got to be careful not to go on tightening forever and ever. And what else do we need to do? I think we'll run over that with some isopropyl alcohol. I'll tell you what, first of all, I'll do that off camera, and what we'll do is get this. I've just got the speaker, I say just, I've got the speaker to worry about. I'll have a look in my stash. Let's turn the test gear off. I'm satisfied everything's right. Put it on the aerial. I'll clean it with isopropyl alcohol and then see if we can find a speaker. Otherwise, we will have to scrap the next set, won't we? "19 a Roger." "19 a Roger." Right, go over that. Well, I've got the dishwasher running, so I decided to put the lids through the dishwasher, and then we've borrowed that speaker off the same radio we borrowed the meter off Mystery Benefactor Allen's Uniden 100. So now it's got even more missing. Alright, let's just see which one is negative and which is positive. Okay, that's negative. Yeah, so that's positive. Just hope it's not a duff speaker after all this. I did check it hasn't got cone rubbing or anything like that. So this is going out when we put this on eBay. It's going out with this brand new mic, and it chances are I'll be going out with a brand new power lead as well. Okay, so we turned out the speaker that I hoped was going to be okay, wasn't okay, so I've changed it again. This time we've pinched one out of a scrap business radio, so it's a bit heftier. So there you go. I knew there'd be another way, because the only thing we can get anywhere close to is $16.99, plus no doubt powers of post and that. I think they're in Germany, that kind of price. So we'll put this in. Although polarity is not important unless you're doing things in stereo, we'll just check which one's negative. Not that one. Am I missing something here? Not that one. That one. And hopefully, well, we've already done the on the air test using the extension speaker. Because I wanted to do the on the air test in daylight, because there's been a lot of rain. I want to see how high the water was at Rorsby Warren. Alright, let's see whether that works. Might be better if I make sure we've got power. Yeah. As usual, he's off. They're always off frequency, aren't they? The Nottingham Burner Brigade. I don't think they're using CB radios. I think they're using naughty radios. So I haven't got any silver screws, so it's going to get black ones. But at least it's going to get new ones. Right, so there we go, all screwed together and with machine screws and not self-tappers. Right, we'll get that one on eBay. Thanks for watching.